This is similarities in a nutshell.
In today's topic, we will be going over similarities.
This topic will include translations, vectors, reflections, rotations, dilations, similar figures, proportions, and proportionality theorems.
The first we'll be going over translations and vectors. A translation is basically a transformation along a vector, so that the distance between the preimage and the image is the same distance and is parallel to the vector.
A vector is the amount of distance and direction between a preimage and the image. This unit is uniform in order to create a translation.
For example, let's take a look at triangle ABC. Triangle ABC is translated on the vector 0, -7. In this instance, the vector 0, -7 would be an example of vector notation, where just the vector is displayed. The second form of a vector would be a coordinate notation, where it shows the specific values you add to each coordinate point in the set. For instance, in triangle ABC, because it's translated on vector 0, -7, all you would do is subtract 7 units from the y value of each coordinate of triangle ABC.
Now let's look at rotations. Rotations are basically a figure rotating around the origin. There's an easy way to remember it.
For a 90-degree rotation, the coordinate x, y is transferred to -x, -y, x. For an 180-degree rotation, the coordinate x, y is transformed to -x, y. And for a 270-degree rotation, the coordinate x, y is transferred over to y, -x.
Now let's look at an example. Let's say we have a point 4, -6. And if we wanted to rotate it 90 degrees, we just make the y negative and the x the same. So thus, it will make it 6, 4.
Now let's take a look at reflections. Reflections occur whenever a shape is flipped over an axis or a line.
For over the y-axis, the coordinate point xy will be -x, y. For over the x-axis, it will be xy to x, -y. For y equals x line, it will be xy to yx. And finally, for y equals -x, it will be xy to -y, -x.
Let's take a look at the example. Let's assume we need to flip square ABCD over the y-axis. Let's take a look at point C. Point C is 2, 2. Since we need to flip it over the y-axis, all we have to do is make the x value negative. So in this case, C prime would become -2, 2. Now let's discuss dilations. A dilation is an enlargement, preservation, or reduction of a figure.
An enlargement is when the scale factor is greater than 1. And a reduction is when the scale factor is less than 1. And finally, a preservation is where the scale factor is equal to 1. Please note that the scale factor is uniform for every point.
Now, the scale factor, for those of you not familiar, is simply the quantity by which you multiply the coordinate points by. To dilate a figure, all you have to do is multiply a coordinate point by a particular scale factor. For instance, let's assume triangle ABC is enlarged by a scale factor of 2. If we have point B, which is 2, 2, all we have to do is multiply both points by 2, making B primed 4, 4.
Now let's discuss proportions. Proportions are important to finding the similarity of equations and figures.
The equations are proportional when you can cross multiply them and their product will be equivalent to each other.
Now let's look at some of the proportionality theorems. In a triangle, we have 3 different proportionality theorems. First is angle. If both of the triangles have the same angle and are congruent to each other, thus we can come to the conclusion that yes, they are proportional. And finally, next is side. If Each side of the triangle is proportional to each other, thus we know both of the triangles are similar. And finally, side angle side. If we know the two sides of the triangle are proportional and the angle equals the same, we can come to the conclusion that it's proportional.
However, bear in mind, in side angle side, the angle we're looking at is the included angle, meaning that the angle is between two lines, such as angle TRQ in this example.
Now let's look at some similar proportions with line segments. Now take this line segment for example. Over here we'll have RT, or let's look at triangles for example. So first we have RT over TQ. Thus we can come to the conclusion that RU is equal to US. This is one of the proportionalities.
The next proportionality theorem would involve this triangle right here, in which AD over DB is equal to CA over CB.
Now finally, let's come to this proportionality theorem. Over here, we look at two parallel lines that are intersected by three other lines. So from here, we can come to the conclusion that UW is equal, UW over WY is equal to VX over XZ.
To give you an example of two proportional sides, let's take these two triangles. Side A over side B should be equal to side C over side D. We can conclude that these are proportional because 4 over 2 is equal to 2 and 12 over 6 is also equal to 2. Thus, the sides are proportional, and if we know that these angles are congruent, then we can conclude that both triangles are proportional. Now let's take a look at similar figures. There are two properties when it comes to similar figures. Of course, you can have proportions, but the figures are also similar if the angles are congruent. And the figures are similar if all of the sides are proportional. Essentially, this is the side proportionality theorem, with this being the angle-angle proportionality, with this being the angle-angle similarity theorem.
Now let's look at some of the examples. And here that we know triangle CBA is congruent to HED, because if you look at here, angle C is equal to angle H, so and angle B is equal to angle E. Thus we can come to the conclusion that angle A and angle D are congruent. Thus we know those shapes are similar. Now finally, let's look at triangle ABC being congruent to triangle DEF. Now we know that AB is equal to 4, so thus DE is equal to 2. So we know it's 2, the sides are being multiplied by 2. So thus, if we can check it, if EF equals 4, then yes, BC has to equal to 8, in which it does. And now please note that this can happen for every single quadrilateral. Each side and angle need to be congruent so they can be similar.
What are you debaters doing?
On top of that, all figures that are transformed, as long as their transformations are identical, are also similar figures. If two figures are dilated by the same amount, then they are similar figures. Or if a smaller figure is when a smaller figure is enlarged, reduced, or preserved, the two figures are similar. Same with translations, same with reflections, and rotations as well. We would like to thank you for taking the time to watch our review video of similar figures. Special thanks to Ms. Patrick for being the superior geometry teacher. Serge was the narrator, animator, and designer. Sanat Nair was the narrator, writer, and cover artist. And Payton was the narrator, producer, and outliner. This video was in association with Patrick Productions Incorporated.
Thank you. Come again.